Hello guys, welcome back to Self-Help Maths Academy. Today we will discuss with epsilon delta definition of limit, or it's also called as precise definition of limit. So we have heard about this definition many a times. Let's understand it thoroughly with the help of the graph, with the help of the examples, more simpler way. So let's see what the definition says. So here, let f of x be defined on an open interval about x naught, except possibly at x naught itself. So we say that the limit of f of x as x approaches to x naught is the number L, and we write it as limit of f of x as x is tending to x naught is equal to L. The same definition we talk in terms of epsilon and delta. So I will explain you what is this definition is all about. Let's see what is this definition is talking about. Okay, so here uh, for every number epsilon greater than 0, there exists a corresponding number, say delta greater than 0, such that for all x 0 less than modulus of x minus x naught, which is less than delta, it implies the modulus of f of x minus L is less than epsilon. So what they're trying to say here is, for every number which is a positive number, in fact, which is greater than 0, epsilon, there exists one delta number. So for every epsilon number, there is a delta number, okay, such that how they're connected? So they're connected in such a way that if you take the modulus of x and x naught, this is less than delta. It implies if this is happening, it happens with, like, say, f of x minus capital L is less than epsilon. So if modulus of x minus x naught is less than delta, then quickly it implies that modulus of f of x minus L is less than epsilon. So this is about the definition. So what is this definition is trying to say? So let's understand it in detail. So what is important here is to know what is this modulus of x minus x naught is less than delta, and what is this modulus of f of x minus L is less than epsilon. So if you understand it, then we will understand what is the relationship between this delta and epsilon. So now actually by looking at the definition, we can just understand that there is some relationship between this delta and epsilon. So maybe they're depending on each other, or they're connected to each other. So let's see in what way they're connected, if at all they're connected. So this particular part, we will understand it now in detail. So let's go with what is given. They've given that modulus of x minus x naught is less than delta. As you all know, this modulus quantity will be containing positive as well as the negative part. So here, this is, like, say, if I take this as x minus x naught is less than delta, one part, and one more is what? So I mean the same thing is leading two parts. So here I just change a color for better understanding. They have given modulus of x minus x naught is less than delta. They have given. So this we can write it as x minus x naught x less than delta, and minus of x minus x naught less than delta. Okay, so this is how we can write it. Now this implies, so here this implies your x is less than x naught plus delta. Since here minus sign is there, I will take this minus sign on the other hand. So whenever you will multiply with the minus sign, so the inequality reverses. So therefore here you can take this minus sign on the other hand. It implies x minus x naught is greater than delta. Okay, so this implies what? X is greater than x naught plus delta. Okay, so here what we have got, sorry, here it is minus delta, because here I'm just changing the minus sign. So therefore when I reverse the minus sign, it is x minus x naught is greater than minus delta. So this implies x is greater than x minus delta. So clearly what we have got now here, we have got x is less than x naught plus delta, and x is greater than x naught plus x naught minus delta. So these are the two important equations we have got. So let's draw it and see how exactly uh, you know it looks like. So if I draw this graphically, if I see, so for example, say this point if I take as some x naught plus delta. So I just change the color for better understanding here. So let me take this as some x naught minus delta because it is minus sign. So it will be coming in the left hand side of the real line. And similarly, I will take here x naught plus say delta. Okay. So clearly x is less than x naught plus delta. So here it is talking about x is less than x naught plus delta. So less than x naught plus delta means all these values you can think of. X naught plus delta less than means the left values. Similarly, it is also talking about the values x is greater than x naught minus delta. Greater than means it is on the positive axis like here this way. Okay, so from here you can think of all the points. So now you can see between these two what is the common lines what you have here is, I mean, the common points what you can think of. You can think of these are the common points. So these are the common points in between x naught minus delta and x naught plus delta. Means here somewhere your x lies. So your x will be lying between this. So that implies what? This implies your x is lying between x naught minus delta and x naught plus delta. The same thing, it is actually the open interval. So we can write it as x belongs to the open interval x naught minus delta and x naught plus delta. So here it implies your x is lying between x naught minus delta and x naught plus delta. Similarly, now we will take up your the next part, that is modulus of f of x minus L is less than epsilon in the similar way. So let's understand. Okay, so here they have given that the same way modulus of f of x minus capital L is less than epsilon. So this implies what? Again, it has both positive and negative values. So here what I'll do, capital f of x minus L is less than epsilon, and minus of f of x minus L is less than epsilon. So as here earlier we mentioned, so this implies f of x will be less than L plus epsilon. Okay, so here if I take minus sign, on the other hand your equality will be reverses, that is f of x minus L will be greater than minus epsilon, and this will be further f of x will be greater than L minus epsilon. So here you have got f of x is less than L plus epsilon, and here f of x will be greater than L minus epsilon. So clearly again if I draw this graph guys on the real line, so clearly you can see that, clearly you can see here. So if I say, if I take this point as say L minus epsilon, because it is minus, it will be lying on the left side of the real line, and similarly if I take L plus epsilon, which is lying on the right hand side of the real line, and they're telling that f of x will be less than L plus epsilon. So f of x will be less than L plus epsilon means these are the values. So it is less than means these are the values which it will be considering. Similarly, if f of x is greater than L minus epsilon, greater than L minus epsilon means here from here it will start, and these are the values which it will be considering. Of course, it will be the positive infinity, and here it is minus negative infinity. So here you can see these are, when these two lines when you're taking, the common part of both the things are here. So this is the common part of it. So again, this implies your f of x lies somewhere in between these two. So in between these two, it implies your f of x will be lying between L minus epsilon and L plus epsilon. So that is the meaning. In other words, your f of x belongs to the open interval L minus epsilon and L plus epsilon. So now what we have got? So from the above two discussion, like from this and this point, what we have concluded here is, so it is clear that your x is lying between, your x is lying between x naught minus delta and x naught plus delta, whereas your f of x will be lying between L minus epsilon and L plus epsilon. So now let's understand guys, here the important part is what we will understand, how this, what is the meaning of this, I mean like whatever we have understood just now. So if I just draw the graph, okay, so let me draw the graph of whatever I just told you. Now see, if I draw the graph of the same, okay, see, if I'm drawing the graph of the same, okay, so say let me take one graph here, any graph, say this is my y is equal to f of x. Okay, and what I do here is I'll be taking any point, say x naught. Say I'll be taking any point x naught here. Okay, so here if I take the point, say x naught, and when I take this point as x naught, clearly what I'll do, I'll be taking some with some left distance here, I'll be taking this as x naught minus delta, and here I'll be taking the point as x naught plus delta. And moreover, delta is very small distance in fact, so for a better understanding we're not taking the distance very closely. Okay, so it is not that this much difference, but just for understanding I'm just taking this distance. Okay, so here you can just take this, and here you can take this line, and here you can take this lines. Okay, fine. So this will be your, this point is your L. Okay, or you can take it as your f of x, L, f of x. So and this will be your L minus epsilon, and this point is your L plus epsilon. So what is the basic meaning of this epsilon and delta? So as your function will be moving, so from this distance to this distance, it has to move from here to here. Okay, so that is either from x minus delta x naught, this x naught has to move either with the this distance, delta distance on the left, or the delta distance with the right. Okay, so within this distance how exactly it will be moving. In the same way, it also, the function also move in this direction. So that means what exactly they're trying to say, epsilon and delta function, what is this definition is talking about is our function will be moving within this range. You can see this range, as my delta is, I mean the distance x naught will be moving left side with x naught minus delta distance, and right side with x naught plus delta distance. The same way our function also will be moving with the positive epsilon and the negative epsilon within this distance. So it cannot exceed this particular path. It will not go away from this. So it will be moving here only. So as it will move here, so it will be moving here. Okay, as it will come down, it will be coming down in this way. So this particular the, what you can see, the graphical representation we can show for epsilon delta. Okay, so let me make it more clear with taking with simple examples, so that you know how this epsilon and as well as delta will looks like. And sometimes not necessary that this distance, whatever the distance you're observing here, so this distance, not necessary that this distance should be equal to this distance, not necessary in some. And actually this whatever the delta and epsilon we're talking about, so the relationship between them will be depending on this function, whatever the function you are considering, depending on this functions your delta and epsilon relationship will be standing on. Okay, so here clearly guys, as I'm earlierly mentioned, that this distance not necessarily should be equal to this distance. I just change a color for better understanding. So here what I'm trying to say, this distance not necessarily should be equal to this distance. In some examples, for in some functions, that distance may be same, that is delta may be say equal to epsilon. In some it may not be equal, it may be having some different values. So all this discussion we will do in the next example. Let's see one example. Okay, and we'll make it more clear. So here, for example, if I take say f of x is equal to x, so f of x is equal to x means you can see your graph how it looks like. I have drawn this graph here. This is your graph of, this is your graph of f of x is equal to x. Okay, let me draw, and let me take one more line here. So the graph looks like this. Okay, so now clearly what we do here is, so this is our graph. What is this? Y is equal to x. This is our graph. Okay, and it is passing through origin, say 0 here. Now what I do, I will take any point, say x naught, any point, say x naught, I mean not here, I'll be taking the point x naught. Okay, let me draw this. This is my point x naught. As we all know, I will take certain distance here, and this will be my x naught minus delta. Okay, and I'll join this. And similarly here, I'll be taking x naught plus delta, and let me join this also. Okay, so clearly we will take here also the associated line on the y-axis corresponding. So yes. So this is the corresponding lines. So this is your x naught minus delta, x and x naught plus delta. Corresponding to x naught, you will be having the point L here, or you can call it as f of x, no problem. And this will be your L minus epsilon, and this line will be your L plus epsilon. So this is what we have known. Now, what I'm trying to say here, we want to know what is the relationship between this delta and epsilon. So let's see, what is your function is given as? Your function is f of x is equal to x, or it is equal to y. That is, your y is equal to x in fact. Okay, this is your graph. Now, if I take the point, say if my point x is equal to x naught minus delta, I'll come from this point. Okay, so if it is x naught minus delta, then y is equal to x. This implies your y is also will be equal to x naught minus delta. Similarly, if suppose if my y is equal to x naught, if y is equal to x naught means it is a x naught only. Then sorry, if I take x is equal to x naught, sorry, if x is equal to x naught, this implies y is equal to x. Therefore, y also will become what? X naught. Y also will become x naught. Similarly, if I take say x is equal to x naught plus delta, since y is equal to x, what about your y will become? It is also x naught plus delta. Okay, so that means what is happening here? So if I take my x is equal to x naught, if your x will be equal to x naught, then your y is equal to x naught. That means here you have got x naught. So correspondingly, this point I'm talking about. Your x is x naught means y is also x naught. So here y is also x naught. So this point will be your x naught. And since your y is equal to your x is equal to x naught minus delta, this implies your y is also is equal to what? X naught minus delta. X naught minus delta means since your L is equal to x naught, this will be what? X naught minus delta. And what about here? It is x naught plus delta. So clearly your x naught is L. Your x naught is L, and x naught minus delta is L minus epsilon. So that means what? By equating this, you will get what? Delta is equal to epsilon. Your delta is equal to what? Epsilon. So in this particular function, y is equal to x. Okay, so you can understand now, as your your function is moving within this distance to this distance, your f of your x naught will be moving from this distance to this distance. Your f of x can move from this distance to this distance. That is the verification. And moreover, delta is equal to epsilon in this particular case. So this delta is equal to epsilon is depending on what? Depending on the function what you are taking. So y is equal to x. So this is what actually the graphical meaning of epsilon delta function. With one particular example we understood. Let's see one more example how this particular graph looks like. Now if I take say y is equal to 3x, or in other words you can say f of x is equal to 3x. So if I draw this graph again, if I draw this graph, so clearly guys you can just see, okay, let me, yeah. So if I just I'll just show you how the points look like first, how the graph looks like first. If I say x and y here, if I take x is equal to 0, y will be equal to 0, because your y is what? Y is equal to 3x. So if x is equal to 1 if I take, then y will be equal to 3. If x is equal to 2 you take, 3 2 is 6. If x is equal to 3, y is equal to 3, that is 9. That implies if you just draw this graph guys, somewhere it looks like this. Okay, I just draw it here. Somewhere it looks like this. Okay, so this will be your y is equal to 3x. So now when I draw this graph, so it is clear that this is your y-axis, this is your x-axis. Okay, and here this is your y is equal to 3x graph. Now what I do, I again take one point here, say this is my point x naught, and clearly here I have to take x naught minus delta, and here I'll be taking say x naught plus delta. Okay, so now correspondingly this point, okay, let us change the, this point will be, and this point will be, and this point will be on the y-axis. So this point will be our L, Okay, and this point will be your L plus epsilon, and this point will be your L minus epsilon. Okay, so this is what we know about it. Okay, so let's see, this is our L minus epsilon. Now clearly what we do here is, again, what is the given function, guys? The given function is f of x, that is equal to 3x, or it is equal to y, that is your y is equal to 3x. Now what I do again, if I take, say, x is equal to x naught, then your y will become what? 3x naught. Your y is equal to 3x naught. And if I take y is equal to, sorry, if I take my x is equal to x naught minus delta, then y will be, since your y is equal to 3x, it is 3 times of x naught minus delta, which is equal to 3x naught minus 3 delta. Okay, so similarly, if I take x is equal to x naught plus delta, then your y will be equal to 3 times of x naught plus delta, that is 3x naught plus 3 delta. So here you can see clearly, when I take x is equal to x naught, your y will be equal to 3x naught. That implies, here this is my x naught, this point will be x is x naught, means y is 3x naught on the y-axis. And similarly, if x naught minus delta is there, this point if you talk about, then this point is x is x naught minus delta, then y will be 3x naught minus 3 delta. Similarly, this point will be x naught plus delta, then it is 3x naught plus 3 delta. So this is what you have, the points here you can see. Okay, so now what I do, if I just see this observation, clearly your L is equal to what? 3x naught. And your L is 3x naught, means L minus epsilon is equal to what? It is 3x naught minus 3 delta. If L is equal to 3x naught is known, therefore what is your epsilon will be equal to? Epsilon will be equal to 3 delta. So here in this case, your epsilon is 3 times of delta. In the first example which I have shown you, where y is equal to x was there your delta and epsilon both are one another same. And here we have epsilon is equal to 3 times of delta. So this means your value of epsilon and delta relation is depending on whom? Depending on the function on which you are defining your limit. Okay, so like this, guys, graphically now you can see, now as your x naught moves from this distance to this distance, your function also moves from this distance to this distance. That is the beautiful meaning of epsilon and delta. Okay, so this is another example, okay, where I can show you, where I've shown you that how the epsilon and delta are connected. Now let me show you one more example, where graphically how do we calculate the delta. So this example, what they have asked is, we have to use the graph of the function f of x is equal to root x, and we have to find out what is delta, such that modulus of x minus 4 is less than delta, and then modulus of root x minus 2 is less than 0.4. Clearly, guys, if you just give a little attention here, your function is given as f of x is equal to root x, and this whatever the quantity they have given, it is matching our definition of epsilon delta definition. So clearly you can see, this is your x minus x naught less than delta, and this is nothing but what? Your function f of x, that is f of x minus L is less than epsilon. So in usual example, if they ask you for delta, they will give the value of epsilon, and if they ask you for epsilon, they'll give the value of delta. So that is the better understanding. And they've also given the graph. So this graph, actually this is the complete graph which I have drawn, but they have given just the graph like this. I'll just show you. So the graph was like this. Okay, let me draw this further. So here the graph of the root x graph looks like this, in fact. So this is your x, and this is your y-axis, and this is your 0. Okay, so this was given, and what else they have given us? They have given you the, yeah, they have given you this point. Let us see this, whatever the graph they have given, on that you can see your L is given as 2. Okay, and they have given you your x naught point. Say x naught, if I take it as 4 here, and this corresponding point, this is your 2. This is given. X minus x naught. X naught is given as 4 and f of x minus L. L is given as 2. This is given. And they've given you epsilon value as zero point 0.4. So epsilon value is 0.4 means if you remember the previous graph, you are having here L and here you are having L minus epsilon. Here you are having L plus epsilon. So L minus epsilon. L is known to you, that is 2. 2 minus zero point 0.4 is 1.6. So somewhere here it is 1.6. So this point, okay. So here you can see this point. This is your 1.6 and I'm drawing it here. I don't know what is this. And similarly, plus, that is L plus epsilon. 2 plus zero point 0.4 is 2.4. So 2.4 means somewhere here I'll take. This is 2.4. And if I draw this, okay. So that is here somewhere. So this is our another point. So this we have to find it out. Okay. So this is the basic graph they have given. So whatever the additional thing that I have just done, I will tell you how we have done it. Okay. So this is a given graph, guys. So first what we have to do is we have to find out what distance. We have to find out the delta. In fact, so delta we need to find out. For that, what we need? Let's see. Clearly, delta means this distance we want. So this is your x naught if you take. This is your x naught minus delta and this is your x naught plus delta. But if you see this practically, this distance, whatever you are seeing, this distance and this distance are not equal. In fact, they are not equal. So this distance is quite bigger than this distance, which you are able to observe easily. So now here also this is also delta and this is also delta. Then which particular delta we are supposed to find out? That may be the question, right? So you can see this distance, if you observe here, this distance is as good as this distance. Okay. So this distance, the whole distance means if you take this as delta, if I want to find out this as delta, this distance as delta, then it implies you have to go below this. I mean, you can see if you just see this distance, so this distance means what? Here you have to come below this 1.6 where the fluctuation is not allowed, because as we know the epsilon delta definition, between, if you are having x naught here and x naught plus delta and x naught minus, sorry, x naught minus delta and x naught plus delta you have, then this as per this fluctuation, it is allowed here in this fluctuation. Similarly, it has to be allowed here what? Between this only. It cannot go beyond this or here. Okay. So with that, if you see, then this delta cannot be considered. Then which delta we have to consider? This delta we have to consider. So for this delta means this distance. Okay. So that clearly you can see this distance we are talking about. Okay. So this distance, when we are talking about, this distance is corresponding to what? You can see this is corresponding to 1.6 and here this is corresponding to what? This. So between this only we have to think about now. So what is given? Let's write it. So this is given that if modulus of x minus 4 is less than delta, this is given. So this is nothing but your limit definition. So we can define only one value for delta as I explained you now, because this delta is quite bigger, the distance which will be taking beyond the value of say 1.6, but as per our epsilon value we cannot take beyond this, so we cannot take beyond this values. So therefore this delta cannot be considered. So what delta we have to consider then? This delta we have to consider. This is the delta in fact. So this distance is delta. So let's find out what is this delta distance will be. So therefore clearly what is given, guys? Clearly your x naught is given as 4. Okay. So your x naught is given by 4 means what is your function? Y will be equal to, y is root x. So x naught is 4 means x is 4, that is root 4, which is equal to 2. So that's what this 2 you have got here. And similarly, your epsilon, what you have got as 0.4. This is also given here. I'm just writing whatever is given thing. So now what we do, so this corresponding, this is what the delta we are interested in. So with respect to this delta distance, what is your corresponding value of y here is, it is 1.6, means function value is 1.6, but your function is defined as f of x is equal to 1.6, so which is equal to root x, which is equal to root x. So this implies 1.6 is equal to root x. Take a square on both the side. it is 2.56 is equal to x. So here 2.56 is equal to x means what is your delta will be equal to. So this is your x. Now this you got. This point you have got. This point is your 2.56. Okay. So this point you have got now. But I am interested in this distance. So this distance I want I means what it is. Delta will be equal to 4 minus 2.56. So delta will be equal to 4 minus 2.56. Therefore, delta value will be 1.44, which is less than or equal to 1.44. So, I've got the delta now. So, this is our 1.44, this distance. So, similarly, here also 1.44. So, equal distance we'll be having. So, here somewhere it comes. So, if I just draw this graph, clearly you can see, I can draw one more line here. If I take this, so here it somewhere here it comes. Somewhere here. Okay, so this point, this point. That means our delta will be allowed only in this distance. It has a fluctuation between this distance. It cannot go beyond this. So that though it has shown here, but it will not take these values. So it will take only between these values. Okay, that is 1.44 means 5.44 up to here. Okay, up to here and up to here. Only this x naught minus delta and x naught plus delta. Your delta will be fluctuating between this, and whereas your function will be fluctuating between this point to here. You can see this blue mark what you are seeing. So from here to here. So this there is a fluctuation. So this is what is the meaning of the epsilon and delta limit function, guys. So this is how we can solve the examples also, and this is how we have to understand graphical meaning of epsilon delta function. So if you have any questions, any doubts, please comment on the box. And if you like the video, please like it and share it to your other friends so that it can reach to many students. Thank you so much, guys. Next week we will come up with the next very important concept. So till then, please take care and see you all in the next discussion. Thank you, guys.